Welcome to sublesson 8.1, where we'll discuss Linux's versatility on the network. Linux, from its very earliest implementation, was designed for the network. It's really where things get interesting with computers when you connect them to other computers to enable advanced communications. Linux's network stack is extremely flexible. You can configure it for just about any type of network out there. Of course, it's very powerful and has a large impact on the internet. It's also present in mobile devices in the form of Android and can be configured to do really whatever you need it to do. It has very widespread acceptance among vendors. This means that virtually any network driver that you need, any network adapter, whether it's a brand new piece of technology or something really old, likely is compatible with Linux. And the great thing about Linux is, even if it's not compatible out of the box, some developer out there can write source code and it will be compatible. Linux is an early adopter of brand new technologies. For instance, the brand new TCP fast open, or fixes for the network problem on the internet known as buffer bloat, were built into Linux before pretty much any other operating system. This means that you can test out new features of the internet that are just being developed early, and you can write applications so that they take advantage of these features. Linux is really a great multi-purpose tool. It can serve a lot of different functions on your network. Let's explore a few of them. On the web, Linux has a great presence. It has a number of powerful web servers. A couple examples are the heavy, very process-based servers such as Apache HTTPD. Out of the box, Apache HTTPD starts as root and spawns a number of subprocesses. It can also be configured to use threads rather than processes. In either case, it's a very thick and powerful web server that can be configured to do what you need it to do. Alternatively, you could use a different approach to web server technology such as Nginx. Nginx is really a lightweight event-based web service. It's actually just a proxy. It accepts inbound connections and proxies them to some application server behind it. Because of this, it's very lightweight, very fast and efficient. It's also asynchronous. You can modify HTTP traffic in transit. It may not have as much features or as much functionality out of the box as Apache, but it certainly suits the needs to run a really large number of today's websites. In addition to front-end web servers, Linux also has support for a number of powerful application server technologies. For example, the very common scripting languages such as Python, Ruby, and PHP are very widely supported, and there's large communities out there to help new programmers get familiar with how to use them, and as well as system administrators how to implement them and scale them properly. PHP is used to power Facebook's entire site, so you know that it's a powerful technology that will serve almost any purpose. On the other hand, there are additional programming languages such as Java and C++ that have great support and application containers on the Linux platform. These are used often for heavy back-end application processing purposes. Linux is also great for a database server on the web. You can run a traditional relational database management system, such as Oracle, or you can run an open source version that would be free and very widely supported by communities, such as MySQL or PostgreSQL. Today, other technologies, known as NoSQL technologies, are gaining prominence as a very fast, performant, different approach to managing data stores. Cassandra and MongoDB come to mind as very popular back-end platforms for supporting high-scale websites without SQL. Linux can also perform as network infrastructure. For instance, Bind is the de facto DNS server. It is measured as the standard by which all other DNS servers are based. It runs the root name servers for the DNS system as well. DHCPD, also from the same organization that writes Bind, is a de facto reference implementation of a DHCP server. So Linux could be used to serve dynamic addresses across your network. Linux can be used as an SMTP email server. SendMail comes to mind as a commonly deployed email server. In addition, there are Postfix and other mail servers out there that you can use to send email across your network. Linux can sometimes be deployed as an NTP time server. You can configure it to make sure that all the systems on your network are in sync and serving exactly the right time. This is important for lots of purposes. For instance, for maintaining security. When a log message is printed, you want to make sure that it had the right timestamp so you can find out what happened at what time. It can also be important for databases to maintain integrity and consistency, especially when multiple database servers are hosting a similar set or shared set of data in a cluster. Linux can be even configured as a network gear. It can be configured as a router, so it sits between your network and the internet and routes traffic between multiple networks. It can be configured as a firewall. In fact, it is the core of many professional firewall products from companies such as Linksys. Linux can be configured as a monitoring server, where it takes as input metrics measured from different systems around your network and alerts you when things aren't quite what they should be. It can be a logging server, as we learned in the syslog section, or it can even be used for analysis of incoming log messages or for network traffic. Finally, Linux can be a configuration management server. Tools such as Puppet and Chef can make sure that the configuration of your network stays in sync at all times, and it helps to prevent different systems from drifting. It's called configuration drift. When systems are changed over time, Puppet and Chef can help make sure that those systems stay the same.